जित मार्ग तुम प्रेरो स्वामी, तित मार्ग हम जाते. Whichever way you turn me, O my Lord and Master, that's the way I shall go. By the Guru's grace, we are just starting unit number 11, Alcohol, Phenol, Ethers, Part 1, Alcohols by Amrik Singh, PGT Chemistry. First of all, we are studying the preparation of alcohol. First method is by acid catalyzed hydration of alkenes. In the second slide, we are seeing alkene are treated with water in the presence of an acid. Then there is the addition of H positive and OH negative on the carbon atoms bearing double bond. We are taking the example of propene, and water is adding according to Markovnikov's rule, and we are getting propane 2-ol. The mechanism for hydration of alkene involves three steps. Number one is the protonation of alkene to form carbocation by electrophilic attack of H3O positive. H2O reacts with H positive to changes into H3O positive. Alkene react with H3O positive and accept one H positive, and carbocation is formed in this process. In step 2, carbocation is attacked by the water, and water acts as nucleophile, and we get protonated alcohol. In the third step, the protonated alcohol loses one proton to water and changes into alcohol, and a hydronium ion is formed. Step number preparation of alcohol. Second method is by hydroboration oxidation of alkenes. In this, alkene react with diborane, but work is done by the BS3. Now, to one carbon of H comes having lesser number of hydrogen on the multiple bond, and to other carbon having greater number of hydrogens, BS2 comes. Now, in the second step, alkene react with the product of first, and we get again BH2H come from CH, and B is linked by the CS2, and again alkene react the product of second step, and we get CS3, CS2, CS2 thrice B, and after this, these three steps are known as hydroboration. And in the third step, the trialkyl borane is treated with water and H2O2. In the presence of a base, it is boiled, and we get 3 moles of alcohol, propane 1-ol, and boric acid is formed. It is the alone method in which the alcohol is formed according to anti-Markovnikov's rule. Now, preparation of alcohol by reduction of aldehyde and ketones. Aldehyde yield primary alcohol, whereas ketone gives a secondary alcohol, as shown. Reducing agent palladium, hydrogen suspended or palladium. The addition of hydrogen on oxygen and a carbon of the carbonyl group takes place, and we get primary alcohol from aldehydes. And ketone again, the addition of H on carbonyl carbon and oxygen takes place, we get the secondary alcohol. Mainly catalysts used are finely divided metals such as platinum, palladium or nickel. Sodium borohydride may also be used. Lithium borohydride, lithium LiAlH4 may also be used. Preparation of alcohol by reduction of carboxylic acids and esters. Here the catalyst used is lithium aluminum hydride, and we can calculate carboxylic acids into alcohol by using lithium aluminum hydride, but it is a very costly reagent, lithium hydride, aluminum hydride. Therefore, for industrial preparation, the carboxylic acids are first converted into esters by treating with alcohols, and esters can be easily reduced by simple reducing agent, hydrogen suspended over platinum or palladium, and we get alcohol. Lithium aluminum hydride is an expensive reagent and therefore used for preparing special chemicals only. Commercially, acids are reduced to alcohol by converting them to esters, followed by their reduction using hydrocarbon in the presence of catalyst. Preparation of alcohol from Grignard reagents. Grignard reagent, RMGX, R is negative attack on the carbon of carbonyl which have delta positive, and the reaction is shown in slide number 2. The adduct is formed which is hydrolyzed by water to form an alcohol. Formaldehyde give, as shown in the third slide, primary alcohol. Other aldehyde will give secondary alcohol, or all the ketones will give tertiary alcohols. Note, the reaction produces the primary alcohol with methanol, secondary alcohol with aldehyde, and tertiary alcohol with ketone, as told earlier. Chemical properties of alcohol. Alcohol has nucleophiles and electrophiles. We are seeing that alcohol can attack on a carbocation and behaves as a nucleophile, and bond between OH is broken in this process. H removes as H positive and leaving its electron on oxygen atom, as shown. Protonated alcohol act as electrophiles. We have the alcohol and H positive is adding on oxygen. We have OH2 positive here. Then OH2 positive, the carbon on which OH2 positive is there is attacked by a nucleophile, and it leaves OH2 leaves the molecule, and SN2 mechanism occur here, and we get the elimination of water. The bond between CO is broken here in this step. Now, based on the cleavage of OH and CO bond, the reaction of alcohols may be divided into two groups: a reaction involving of OH bond, reaction involving of CO bond. Chemical property of alcohol, reaction involving cleavage of OH bond. First of all, acidity of alcohols. Alcohol reacts with sodium and produces hydrogen gas and sodium alkoxide. They also react with aluminium and form hydrogen gas. The production of hydrogen gas indicates that there is the existence of H positive somewhere, and alcohol have acidic nature. The acidic character of alcohol is due to the polar nature of OH bond. An electron releasing group CS3C2H5 increases electron density on oxygen, tending to decrease the polarity of OH bond. This decreases the acidic strength. For this reason, the acidic strength of alcohol decreases in the following order. Simply, we have seen primary alcohol are stronger acids, secondary weaker, and tertiary are very much weaker acids. Now, chemical property of alcohol again, reaction involving cleavage of OH bond, esterification. Alcohol and phenol react with carboxylic acid, acid chloride and acid anhydride to form esters. The reaction with carboxylic acid and acid anhydride is carried out in the presence of small amount of concentrated acid. The reaction is reversible and therefore water is removed as soon as it is formed to shift the reaction in forward direction. Reaction is given below. ROH, we are treating the alcohol with carboxylic acid and we are getting the ester. We are treating the alcohol with anhydride, again we are getting the ester. We are treating the alcohol with acid chloride, again we are getting the ester. Now, chemical property of alcohol, reaction involving the cleavage of CO bond. Reaction with hydrogen halide, already done. Reaction with phosphorus trihalide, already done. Dehydration, alcohol undergo removal of molecule of water to form alkene on treating with protic acid. Concentrated H2SO4, H3O4 or anhydrous zinc chloride alumina are used as catalyst. We have is the role of it is the rule for organic chemistry. If there is existence of H and OH on the adjacent carbon atom and we heat this molecule, then there will be the elimination of water molecule, and alkene will form. H will remove as H positive and OH will remove as OH negative. Now, primary alcohol H2SO4 is required. The dehydration is somewhat difficult for 3 Kelvin. Secondary alcohol 85% is 3PO4 may do the work and temperature will be 3 Kelvin. Again, alkene will form. Tertiary alcohol work is very easy. 20% S34 may be done, may be used, and 3580 Kelvin is the temperature. Again, we get alkene and water molecule. Now, chemical properties of alcohol reaction involving the cleavage of CO bond. Again, mechanism of dehydration. It again involves 3 steps. First is the protonation. The O of alcohol attack on the H positive and protonated alcohol is formed in second step. Protonated alcohol remove water molecule because oxygen take electron and eliminated as water, and carbocation is formed. Now carbocation, the removal of H positive and alkene will form in the step number 3rd. Fourth is the oxidation. Oxidation of alcohol involves the formation of carbon oxygen double bond with cleavage of OH and CH bonds. As shown, OH and CH bond are broken and there is double C double bond O between carbon and oxygen. And oxidizing agent may be KMnO4 in the presence of H2SO4, K2Cr2O7 in the presence of H2SO4, CrO3 in the presence of H2SO4. Copper at 573 Kelvin, dehydration may be done. PCC is only the reagent which can stop the reaction at aldehyde stage. All the other reagent convert alcohol into carboxylic acid as the end product. Tertiary alcohol do not undergo oxidation reaction under strong reaction conditions such as strong oxidizing agent KMnO4 and elevated temperature. Cleavage of CC bond takes place and a mixture of carboxylic acid containing lesser number of carbon atoms is formed. पई परापत मानुक देहोरिया गोविंद मिलन की यह तेरी बरिया. This human body has been given to you. This is your chance to meet the Lord of the universe. Thank you for watching my video. Thanks.